Summary measures. Standard deviation. Let us now move on to standard deviation. We mentioned earlier that variance is the sum of the squared difference between the observations and the mean. Here, the standard deviation is the positive square root of the variance. In this formula, recall that the unit of measurement of the variance is squared. If you get the square root of sigma squared, then you get sigma. The Greek letters are for parameters. Sigma, as the population standard deviation, is a parameter, while the English letter S for sample standard deviation is a statistic. In standard deviation, its unit is the same as the unit of measurement of the observation. It is now easier to interpret. Take note that the standard deviation, just like the mean, may be distorted by outliers. Why? In the formula, let us recall that we get the difference of each observation from the mean. If there are outliers, the difference will be large. The fact that you need to square that difference, then its value will balloon. If we know that our data has outliers, we better use the coefficient of variation, which is our next topic after this one. Lastly, standard deviation cannot be negative, because from the formula, you need to get the square root. Because of that, the square root of any number is positive. Let's just have this remark. If there is a large amount of variation in the dataset, then, on the average, the data values will be far from the mean, hence, the standard deviation will be large. Otherwise, the standard deviation will be small. Again, we prefer the standard deviation since its unit of measurement is the same as our dataset, and therefore, much easier to interpret. Let us have here a simple illustration. In this example, all the runners of Team Red have the same heights of 191 centimeters. Thus, the standard deviation is simply 0. Let us recall. Measures of absolute dispersion is used to compare two or more datasets with the same means and the same units of measurement. Then, we can compare this one with another dataset with the same mean. Assuming that we have here another team. Team Blue, with the following height measurements in centimeters: 186, 192, 190, 200, and 187. If we compute for the standard deviation of the heights of runners in Team Blue, we will get a value equal to 5.57 centimeters. Now, we have two datasets here with the same means and the same units of measurement. We can now compare them using the standard deviation. We can say that Team Red has more uniform heights than Team Blue. Or we can interpret the complement and say that Team Blue has more variable heights than Team Red. Let us appreciate more the standard deviation in the next slide. This slide shows the same dot plot earlier of the three datasets A, B, and C. If we compute for the mean of each dataset, the mean is equal to 15.5, and it is located somewhere in the middle. But then again, if you look at the distribution of the observations, they differ in terms of their scatter from the mean. Earlier, we said that data B has observations whose distribution is closest to the value of the mean of 15.5, and dataset C has observations farthest from the value of the mean of 15.5. To confirm our answers, we computed for the standard deviation. Dataset C has the biggest standard deviation with a value of 4.57 units, and the smallest standard deviation is dataset B with 0.9258 units. What does this mean? The bigger the value of the standard deviation, the more dispersed are the observations from the mean. Thus, we say that dataset C is the most variable dataset, and dataset B is the most uniform with respect to the mean. Now, before we leave this slide, take note that we use two ways to determine the variability of the dataset. One is through dot plot by inspection, and the other one is through the computation of the standard deviation. Be reminded that there should be 2 or more datasets with the same means and the same units of measurement for us to compare and determine which data is more variable. If you have only one dataset, we cannot say that it is variable based only on the value of the standard deviation. We just know that the observation deviates by that much from the average value. Let us have this example on how to compute for the standard deviation. Consider the pretest scores of 8 sampled participants in a descriptive statistics training course. So the pretest scores are 10, 12, 14, 15, 17, 18, 18, and 24. First, we need to compute for the mean, and we will get that simply by adding all of the observations and divide it by the total number of observations, and we will get 16. Now, plugging in the values, we will now have the computed standard deviation of 4.3095. And we say, on the average, the pretest scores of the sampled participants deviates from 16 by 4.3095 points. This is what I am telling you earlier, that since we only have one dataset, we can only say that the scores deviates from 16 by around 4 points. And again, the computation will be straightforward in MS Excel. You just have to type in the formula of the mean and the standard deviation in the cell provided.